again says a problem, and this is a part C problem. So that is 5 marks problem. Attending part C problem is like playing snakes and ladders. Why? Because if your answer is correct, then you get 5 marks. So you jump with a 5 marks. And if your answer is wrong, then you will lose 6.25 marks. See? So this is like playing snakes and ladders. So be careful when attending part C problem. Be careful. Okay. Here I am going to draw the graph of this problem because it will help you to understand the problem. So what is the problem? A particle of mass m moves inside a bowl. Okay. There is a bowl and a particle is moving inside. If the surface of bowl is given by equation, that is z equal to 1 by 2 a x square plus y square, where a is constant, then the Lagrangian of particle is. So this is my problem figure. This is the z axis. Here first you have to look into the given options, because then only we get which coordinate we have to use. Here you see r coordinate is used, phi coordinate is used, and in this option r coordinate is used, phi coordinate is used. In this option theta coordinate is used, phi coordinate is used, and r coordinate is used. In this option r coordinate is used, phi coordinate is used. So can you find out the odd one among these options? Which one? Yeah, the one which has theta coordinate. So mostly this will not be the correct answer. Here, what are the coordinates given? The given coordinates is r is there, right? And other coordinate phi is there. Theta is not given. We are excluded this option, right? Because this is the odd one among all the three. So there is no other coordinate, right? And you look into the problem figure, and can you relate this coordinate with the coordinate system? So here this problem has certain symmetry, that is cylindrical symmetry. So the coordinates we are using are cylindrical coordinates, that is r, phi, z. Okay, so we are going to solve this problem in cylindrical coordinates, then only we get the given options. Okay, so what is the first step? We have to use the general equation, that is L is equal to half m x dot square plus y dot square plus z dot square minus v. So we have to find out this x value, y value and z value. What is the values of x, y, z in cylindrical coordinate system? Yes, I already told you all these answers. Are you remembering? The x will be equal to, in cylindrical coordinates, r cos phi, and y will be equal to r sin phi, and z will be equal to z itself. So we can find out x dot, right? That is x dot will be equal to, here two variables are there, one is r, one is phi. So r dot cos phi minus r sin phi, phi dot. And what is y dot? This will be equal to r dot sin phi plus r cos phi, phi dot. And what is z dot? It is equal to z dot itself. Now we have to find out x dot square, y dot square plus z dot square. So what we get? We are taking x dot square. Okay, so we get a. So here what we get? L equal to half m x dot square plus y dot square, taking the first two terms. So we get r dot square into cos square phi plus sin square phi, And we know this cos square phi plus sin square phi equal to 1. So we get r dot square plus taking last time, square of last time. So we get r square phi dot square sin square phi, and here we get r square phi dot square cos square phi. So we get r square phi dot square. And here the combination terms will cancels out. One is positive and one is negative. If you have any doubt, you please take square of this function and solve. Okay, so next one is we have to consider z dot square. Here in the problem the z value is given. Okay, that is z equal to 1 by 2 a x square plus y square. And you substitute this x value and y value here. So what you get? You get this is equal to 1 by 2 a r square. Okay, and take the derivative of this function. So what do you get? Z dot will be equal to a r dot. So this time z dot square will be equal to a square r dot square. Okay, minus potential v. See here we are taking this point as origin, choosing as origin. So this is the position of z coordinate, and this will be the corresponding potential mgh, that is mgz, that is v equal to mgz. And we know this z is equal to 1 by 2 ar square, that is equal to 1 by 2 mg a r square. So I am substituting here, that is minus 1 by 2 mg a r square. Now I got the Lagrangian. Now I am rewriting this equation, that is L is equal to 1 by 2 m, because here 1 by 2 m is there, here 1 by 2 m is there. So into r dot square plus r square phi dot square plus a square r dot square minus g a r square. Now look into the options. Which one will be the answer? Yeah, option D, right? Here this one also a CSIR problem, and it is a part C problem. Here the question is to find out Lagrangian. Okay, Lagrangian of a 2D simple harmonic oscillator. In the problem itself, everything is clearly specified. So it is related to Cartesian coordinates x and y. So we have to take only two coordinates, one is x and one is y. And the relation of x is given, that is x equal to theta eta, and relation to y is given 1 by 2 theta square minus eta square. Okay, so kinetic energy will be equal to half m x dot square plus y dot square. Okay, it is simple. You have to take the derivative of this x and the y. So you get the kinetic energy. And the only confusion maybe you have is about potential energy. What is the potential energy of a 2D simple harmonic oscillator? You know it is equal to half k x square plus y square. Here we have to find out the Lagrangian in terms of omega, because options are in terms of omega. So what is the relation between k and omega? We know k is equal to m omega square. So the potential is half m omega square x square plus y square. So substitute x and y values here and solve. So you can easily solve this problem. The only difficulty is they are using some uncommon symbol theta, eta. Okay, so writing this theta, writing this eta may be time consuming work. That is the only difficulty in this problem. So find out x dot, y dot and find out velocity, then add both. So you get the answer. And the correct answer will be option B. Check it by yourself. Okay. We already discussed the general form of Lagrangian in different coordinates. For Cartesian coordinate system, that will be equal to half m x dot square plus y dot square plus z dot square minus v. Right? And what is for cylindrical coordinates? And what is for polar coordinates? Are you remembering? And what is for spherical polar coordinates? For spherical polar coordinate, I tell you L is equal to half m r dot square plus r square theta dot square plus r square sine square theta phi dot square minus v. Now an example problem. What will be the Lagrangian of a spherical pendulum? What is a spherical pendulum? It is similar to simple pendulum. You see. And you know, this is the axis, vertical axis. And you know, simple pendulum will oscillate in a vertical plane only. But spherical pendulum will oscillate in a circular path like this. Okay. And here this angle is theta and it is rotating with the angle phi and this is length r. Then what will be the Lagrangian of this spherical pendulum? Here which coordinate system we will use? We will use spherical polar coordinate system. But in this particular case, you see theta is varying and phi is also varying. But r is constant. It is not varying. Okay. So there is no velocity component in the r coordinate. Okay. But theta dot will be there. Phi dot will be there. So for spherical pendulum, the equation will be Lagrangian will be equal to 1 by 2 m. This r dot will not be there. That is r square theta dot square plus r square sine square theta phi dot square minus v. Another example problem. Here two masses. These are the two masses and are connected by a rigid rod. And these masses can move only along this axis. And this angle is theta and this length is L. Then construct the Lagrangian. So first step is choose the origin. I am choosing this point as the origin. So this is my x coordinate and this is my y coordinate. And this is the mass m1 and this is mass m2. So I am taking first m1. So what is the x value corresponds to m1? That is 0. Okay. It is at the y axis. So this is 0. And what is y value? Y value is this one, right? That is L cos theta. So y equal to L cos theta. Now I am considering the second particle, that is M2. This is the M2 particle. So for M2, what is x value? X is this one, that is L sin theta. Right? And what is y value? Y is equal to it is 0. It is on the x axis. And suppose I am considering these two masses are m1 equal to m2 equal to m. Here next we have to find out x dot So here it is 0 and we have to find out y dot. So y dot is equal to minus L sine theta theta dot. And here x dot will be equal to L cos theta theta dot. And y dot is equal to 0. Now we can write the kinetic energy term, that is T is equal to half m x dot square plus y dot square, that is equal to 1 by 2 m x dot square is L square theta dot square cos square theta plus L square theta dot square sin square theta. So we get L square theta dot square. And you find the potential energy. Okay, here you can see for this mass there is no potential energy, and potential energy is for only this mass. Okay, so find out the potential energy and write down the Lagrangian. So work for you. Now let us discuss a small concept. The concept is Lagrange's equation. Lagrange's equations of motion are invariant under Galilean transformation. This is the idea. So here I am considering two reference frames. This is S frame and this one is S dash frame. And there is a particle, and I can represent this particle with respect to my S frame, that is Ri vector, and from S dash frame, that is Ri prime vector, and this S dash frame is moving with a constant velocity v0 with respect to S frame. Okay, and I am taking a condition, that is at a time t equal to 0, S and S prime coincides. Okay, so I can find out this distance, that will be equal to v0 t, because that is the velocity of this S dash frame and t is the time taken by it. So the distance traveled by it will be v0 t. So here you can see there is a triangle is formed. So I can write Ri vector equal to v0 t plus Ri prime vector. So I can find out the Ri prime vector, that is equal to Ri vector minus v0 t. Now I am taking d by dt of this equation. So what we get? I get vi prime vector equal to vi vector minus v0 vector. And I am considering Lagrangian in S frame. So in Lagrangian in S frame is half m v vector square minus v, that is potential energy. Okay, and in S dash frame I am taking L prime, that will be equal to 1 by 2 m v prime square minus v. And what is v prime? Here we know v prime is equal to 1 by 2 m into vi vector minus v0 vector all square minus v. So I am expanding this term, that I get L prime equal to 1 by 2 m into vi vector square minus v, this one minus v, minus m vi vector dot v0 vector plus 1 by 2 m v0 vector square. Here you can see this term is nothing but our L. So I can rewrite this as L prime equal to L plus 1 by 2 m V0 square minus m Vi vector dot V0 vector. I am rewriting this equation once again, that is L prime equal to L plus d by dt of 1 by 2 m V0 vector square t. So when we are taking the d by dt, this t will cancels and we get half m V0 square. Okay, and Vi is nothing but Ri by dt. Okay, so this will be equal to minus m Ri dot V0 vector. So this is a function of R and t. So I can write L prime is equal to L plus df, that is function of RT by dt. I told you this equation before, that is this equation is called gauge invariance. Gauge invariance of Lagrangian. That means the equations of motion will be same. And we got this equation by Galilean transformation. So we can say Galilean transformation are invariant. That is Galilean transformation of Lagrange's equation are invariant. Okay. Another CSIR problem. Here one Lagrangian is given and they are asked to find out the type of system. Sometimes just by looking into the Lagrangian, we will not get sufficient information. Here you see, for this Lagrangian, we will not get much information. So what we do? We find out the corresponding Lagrange's equations of motion. So we get the equations of the system in a motion. So we can more easily identify the system. So what is the Lagrangian here? It is equal to 1 by 2 m x dot square minus 1 by 2 k x square minus k x x dot t. So the generalized coordinate is x. Then d by dt of dou L by dou x dot minus dou L by dou x equal to 0. That is our equations of motion. Then what will be this value? D by dt of dou L by dou x dot, that is m x dot. And here also x dot is there. Therefore minus k x t minus dou L by dou x. So that will be plus k x. And here also there is a x time. So we get plus kx dot, that is mx double dot minus k x dot t minus kx plus kx plus kx dot t equal to 0. Here kx dot t, kx dot t cancel and kx minus kx will cancel. So what we get? We get mx double dot equal to 0. What is this double dot? That is d square by dt square of x. That is nothing but acceleration. That is ma equal to 0. Here we know the particle mass never be 0. This is not equal to 0. Then what will be the 0? A will be equal to 0. That is, there is no acceleration. In the option, they given about harmonic oscillator and free particle. So what is the acceleration of a harmonic oscillator? Suppose I am taking a simple harmonic oscillator. This is mass m and this is its mean position and it is oscillating about this axis. Okay, and you can see when this mass is at this end, its velocity will be equal to 0. And the velocity will be maximum when it is at the center. So in this motion, its velocity is changing. Therefore, acceleration is not equal to 0. So whatever may be, if even it is a damped harmonic oscillator or undamped harmonic oscillator, there will be acceleration. But here in the equation of motion, we got acceleration of the body is 0. That means this is corresponds to free particle. Free particle means there is no force acting on a particle. That is, F equal to ma. If there is no force, that is F equal to 0, then m will not be equal to 0. Then what will be the 0? Acceleration a will be equal to 0. So this is the Lagrangian corresponds to a free particle. Right now, I know you are masters in constructing Lagrangian from general equations. What is this general equations for Cartesian coordinate system? Lagrangian L equal to 1 by 2 m x dot square plus y dot square plus z dot square minus b. And what is this general form in cylindrical coordinate system? L equal to write it here. I know you know this equation, right? And another one, what will be the general equation for Lagrangian in polar coordinate system? What it is, and what it is in spherical polar coordinate system. If you forgot any of this, please refer back the class and write it here. Now I am going to tell you some tricks and tips. So without solving all the equations, you can easily find out the corresponding Lagrangian by just looking into the problem. But there is a condition. In the problem, they should specify the diagram. Then it will be much easier, or you have to draw the diagram specified in the problem. So this method is mainly based on graphical. There is no much mathematical equation derivation like finding out the corresponding x dot value, y dot value and z dot value. Just look into the problem, how it looks, and you have to find out the velocities, corresponding velocities of each bodies, and just add those velocities. That is the method, and I call that method as superposition method. So first I told you how to construct a Lagrangian purely from equations. That is general equation we know. So Cartesian coordinate system, this is L, and we know for other coordinate system also. And right now I am going to solve the problem using superposition method. That is a tricky method. But to solve a problem by using superposition principle, some prerequisites are there. You should know some ideas, some concepts, then only you can use this tricky method. The first one is you should have an idea about length elements. In mathematics, we represent these length elements are h1 du1, h2 du2 and h3 du3. And what is this h1, h2 and h3? These are called metric elements. And this du1, du2, du3 are coordinates. That is, for Cartesian coordinate system, du1 will be dx, du2 will be dy and du3 will be dz. Similarly, in spherical polar coordinates, this will be dr, d theta, d phi. Now first I am considering Cartesian coordinate system. In Cartesian coordinate system, what is the value of h1, h2 and h3? This will be 1, 1, 1. And du1, du2, du3 will be dx, dy and dz. Then what will be the length element? See, this one is the equation for length element. So what we get? We get length element equal to one into dx, 1 into dy, 1 into dz. That is dx, dy, dz itself. And these are dx, dy, dz are sides of a elemental cube. Then what will be the volume element? Definitely it will be the product of these three, that is dx, dy, dz. Volume element means dv. Okay, dv equal to dx, dy, dz. And what will be the velocity element? That is, I have to take derivative of dx, that is dx by dt, and dy by dt, and dz by dt. You know dx by dt is nothing but x dot, dy by dt is nothing but y dot, and dz by dt is z dot. So I know the velocities in each coordinate, that is x dot, y dot and z dot. Then what will be the total velocity? That is v square will be equal to x dot square plus y dot square plus z dot square. Please remember, these are the velocities in each coordinate. And if we get v square, then our Lagrangian will be equal to 1 by 2 m x dot square plus y dot square plus z dot square minus v. Next, I am considering plane polar coordinate. In plane polar coordinates, the metric elements are 1 and r, and coordinates are dr and d theta. So I get length element, that will be equal to h1 du1, that is 1 into dr, that is dr itself, and another one is h2 du2, that is r d theta. Here you see, this is a plane polar coordinate system, so here we cannot consider the volume, but here we can consider area. So area element will be r dr d theta. And what will be the velocity element? This will be dr by dt, that is r dot and r theta dot. So we get velocity v square equal to r dot square plus r square theta dot square. So Lagrangian will be 1 by 2 m r dot square plus r square theta dot square minus v. Here please remember, these values r dot and r theta dot, these are the velocity elements in a plane polar coordinate system. Next one is cylindrical coordinate system. In cylindrical coordinate system, the metric elements are 1, rho, 1, and coordinates are d rho, d phi and dz. Then what will be the length elements? It will be h1 du1, that is d rho, h2 du2, that is rho d phi, and h3 du3, that is dz. Then volume elements will be, that is dv will be equal to rho d phi dz. And the velocity elements, that is the derivative of length element, that is we got rho dot, rho phi dot and z dot. So we get velocity v square equal to rho dot square plus rho square phi dot square plus z dot square. So we get Lagrangian L as 1 by 2 m rho dot square plus rho square phi dot square plus z dot square minus v. Okay, here also please remember this velocity elements, rho dot, rho phi dot and z dot. Fourth one is spherical polar coordinate system, and the metric elements are 1 r sin theta, and coordinates are dr, d theta, d phi. Then what will be the length elements? Write it here. Okay, it's a work for you. Then write volume element, and velocity elements, the velocity elements will be r dot, r theta dot, r sin theta, phi dot, and we get v square equal to r dot square plus r square theta dot square plus r square sin square theta phi dot square. So we can write the Lagrangian. It's a work for you, and these are also work for you. But remember these values. You have to remember these velocity elements in spherical polar coordinates to use our tricky method, superposition method. Okay. The next prerequisite is, second one, you should know about addition of velocities. Here I am taking two velocities. One is v1 and other is v2. So these are vectors. So v1 vector plus v2 vector. By adding these two terms, I get a vector, that is v vector. And what will be this v vector? You know the parallelogram law of addition. So v vector will be this one. See, this one will be v1 vector plus v2 vector. Then what will be v vector square? That will be equal to v1 vector plus v2 vector all square. That is equal to v1 vector square plus 2 v1 vector dot v2 vector plus v2 vector square. That is v vector square. So what we get after taking the squares? We get v square equal to v1 square plus 2 v1 v2 cos theta plus v2 square. That is, we got v square equal to v1 square plus v2 square plus 2 v1 v2 cos theta. So here this one is the angle theta. So for the different angles theta values, we get different velocities. Now I am considering three cases. One is theta equal to 0. Another one is theta equal to 90 degree, and third one is theta equal to 180 degree. So when solving a problem, most of the time the theta will be 0 or theta will be 90 or 180. Suppose if theta equal to 0, then cos theta will be equal to 1. Then we get v square equal to v1 square plus v2 square plus 2 v1 v2. And if theta equal to 90 degree, then cos theta will be 0. So I get v square equal to v1 square plus v2 square, and if theta is equal to 180 degree, then cos theta will be minus 1, then we get v square equal to v1 square plus v2 square minus 2 v1 v2. Here I can rewrite this equation, that is v square is equal to v1 plus v2 all square. So I get v equal to v1 plus v2. So if theta is 0, then you can directly add the velocities. That is, angle is 0 means this is v1 and this is v2. So the resultant velocity will be v, that is v equal to v1 plus v2. Okay. Here you see the angle is 0. And here, if the angle between two vectors are 90 degree, that is v1 is this one and v2 is this one. So here this angle is 90 degree, then resultant will be v1 square plus v2 square. And here you can rewrite this v square is equal to v1 minus v2 all square. That is v equal to v1 minus v2. Suppose the velocity is v1 is like this one and v2 is this one. Here you can see the angle between them is 180 degrees. Then the resultant vector will be this one, v equal to v1 minus v2. The third prerequisite is you should have an idea about motion of rigid body and motion of a particle. And I told you there are three types of motions. One is translation, rotation, and the rolling. Rolling is a combination of translation and rotation. Okay. So suppose there is a body of mass m is here and it is translating in the x direction. So there will be a velocity and this velocity will be x dot. Then the translational kinetic energy will be equal to half m x dot square. If the particle is in a rotation motion, then there will be a rotational kinetic energy, that is t rotational, that will be equal to 1 by 2 I omega square, where you know omega is equal to angular velocity and you know I is equal to moment of inertia. And what is moment of inertia? You know I is equal to m r perpendicular square. This is very important, perpendicular square. I already told you two cases. Suppose a particle is there, it is rotating about an axis. Suppose this is a z axis and this particle is rotating like this. Okay, about z axis it is rotating. And here I am taking this point as my reference point 0 0 and this is r. Then here the r perpendicular will be equal to, that is perpendicular distance from axis will be equal to r itself. So we get I is equal to m r square, that is r perpendicular is r. Okay, now I am considering another case. This is the axis and particle is rotating about this axis. But my reference point is right now it is here and this distance is r. The distance from reference point is r. Then what will be r perpendicular? Suppose this is angle is theta, then r perpendicular is this one and it will be equal to r sin theta. So here I will be equal to m r square sin square theta. Okay, so be careful about this definition r perpendicular. Okay, and the last one is rolling motion. In a rolling there is a translation kinetic energy and rotational kinetic energy. So total kinetic energy will be T translational plus T rotational. And we know T translational, we know that is half mv square plus half I omega square. Here what is this I? For particle, you know this is I. I is equal to m r perpendicular square. Suppose I am taking a rigid body. Then what will be the I value? Suppose this is my rigid body and it is rotating about an axis. Here you know how to find out the moment of inertia of a particle. But in the case of rigid body, you see the mass is distributed. Then how we can calculate the moment of inertia? Here I am considering this entire mass of the body, that is total mass of the body is m, and I am considering the entire mass of the body is concentrated at this point. That is its center of mass point. And this distance I am taking as radius of gyration k. Then I can redraw this figure as this one. Now the entire mass of the rigid body is concentrated at this point, and this point is rotating about this axis. So here radius is k and mass is m. So this case is now similar to the case of a particle. So what will be the moment of inertia? I will be equal to m into k square. By converting the distributed mass into a point mass, the physics will not change. So I for a rigid body will be m k square, where k is the radius of gyration. And radius of gyration is defined as distance between point of suspension and its center of mass. Okay. And the center of mass and center of gravity has certain differences, but most of the cases the center of mass and center of gravity will coincide. And I think you know the omega is equal to v by r. Now I am substituting this value of I and the omega in this equation. So I get T equal to 1 by 2 mv square plus 1 by 2 I is mk square into omega square is v by r whole square. That is T equal to half mv square into 1 plus k square by r square. This will be the kinetic energy of a body in rotation motion. It's very important. And for translation motion, this will be T equal to half m x dot square. And for pure rotation, T rotation will be half I omega square. Please don't forget these values. It's very important. Okay. The fourth prerequisite, you should be familiar with the circular motion. Suppose there is a ring and its radius is r and it is rotating with an angular velocity, that is omega. Now I am considering a point at this location. Then what will be the velocity of this point? That is linear velocity. And that linear velocity v will be equal to r omega. Now all the prerequisites are over, and now you are ready to use this superposition principle, the tricky method of finding out the Lagrangian. Okay. Yes. Now we are going to discuss about superposition method. It's a super method. Very easy method. But all the prerequisites should be in your mind. Then only you can use this method. Okay. What we have to find out? We have to find out the Lagrangian. And we know Lagrangian is L equal to T minus P. And I already told you how to find out the, and it is almost simple. And finding the kinetic energy is little difficult thing. Why? First we have to choose our origin. Then we have to find out our coordinate x and y. Then we have to find out the velocities in those coordinates. Then we have to find out the velocity v square. Then you can construct the kinetic energy. If you got kinetic energy and potential energy, we can write Lagrangian. In superposition method, we are not bothered about x and y, and we are not going to calculate x dot and y dot, but we directly jump to velocity. Just by looking into the problem figure, we directly write what is the velocity. How we can do this? I tell you an example. An example of a simple pendulum. This is my simple pendulum. Length is L, mass is m, and this angle is theta. And you know this will oscillate like this. And what is our usual method of constructing the Lagrangian? We choose the origin, then we write the equation for y coordinate and x coordinate. Then we find out x dot and y dot, then we find out v square. Okay. Here now I am going to use the superposition method. Here first you have to find out what are the velocities in this problem. This problem is in a plane polar coordinate system. So in plane polar coordinate system, the velocity elements are r dot and r theta dot. Here you know the r is L and this is a constant value. So r dot will be equal to 0. So there is no velocity element in the direction of r. But you can see this angle theta is varying with respect to time. So there will be a theta dot, that is velocity. So this time will be there. So the particle, here this particle is moving with a velocity that is L theta dot. So this will be the velocity of the particle. So we can directly write the kinetic energy, that is half m v square. We know what is the v value. V is equal to L theta dot. So we get kinetic energy is equal to half m L square theta dot square. So we can write Lagrangian is equal to half m L square theta dot square minus mgl cos theta, that is plus mgl cos theta. See, this one is a very simple method. You have to know what is the velocity element in each coordinate system, in Cartesian, polar, spherical, polar coordinate and all. Then you can easily, just by looking into the problem, you can write the kinetic energy. So the time consumption in solving a problem will be hugely reduced. And you know, the CSR will give you only 2 rough sheets and they will not provide any additional sheet to solve any problems. So we have to use that given rough page wisely. Then only we get sufficient space in the rough sheet to solve all the problem. If you're spending half a page to calculate x dot, y dot and the v square, then you can solve all the problems. That's the issue. So this method will really help you to reduce the use of rough sheet. So this kind of tricks are very important in cracking the competitive exams. Okay, now I'm going to discuss another problem, example problem. The another example is spring pendulum. This is a spring pendulum. See, it will oscillate like this. Here when the mass is at this position, the spring will contract. So this total length is L plus x and this is angle theta. Now you can see there are 2 velocities. One is due to the elongation and the contraction of the spring. That will be in this direction. And that velocity will be equal to x dot. See here, L is a constant value and only variable is x. So this velocity will be equal to x dot. And this mass is oscillating. So at this position, its velocity vector will be like this. That is, these two velocity vectors are at a 90 degree. And what will be this velocity? This will be equal to, similar to our simple pendulum, L plus x theta dot. Here you see the angle theta equal to 90 degree. And if theta is in 90 degree, then v square will be equal to v1 square plus v2 square. So we get v square equal to x dot square plus L plus x all square theta dot square. Then the kinetic energy T will be equal to half m x dot square plus L plus x all square theta dot square. And what will be the potential energy? Here potential energy is due to spring is there and due to gravitation is there. So the potential energy due to gravity, we will get minus mg L plus x cos theta. And due to the elongation or contraction of spring, we get a potential energy that will be equal to half k x square. So you can write the Lagrangian, that is t minus v, and write it here. Another example problem. A block is here and whose mass is capital M and a pendulum is attached to it and its mass is small m, and this pendulum is oscillating like this, and this mass is also moving in the x direction. So there will be a velocity x dot. The question is to construct Lagrangian. So we know Lagrangian is equal to t minus v. But here there are two masses, 1 and 2. So first we are considering the mass capital M. For the mass capital M, what will be the kinetic energy? See, it is moving with a velocity x dot. So the kinetic energy will be half m x dot square. And what is its potential energy? Is in the axis itself. Suppose this is the axis. So y coordinate is 0. So there is no potential. V equal to 0. Now we have to find out the kinetic energy and potential energy of small mass m. So here you can see this is angle theta. And for this mass m, what are the velocities? You know, the small m is attached to capital M. Therefore, the small m is also moving with the velocity x dot in the x direction. Okay, and this mass is oscillating in this axis. So there will be a velocity that will be v2. So I am taking this as v1 and this is v2. And what is this v2? Suppose this length is L, then this v2 will be L theta dot. I told you the velocity elements in a plane polar coordinates are r dot and r theta dot. Here this r value is equal to L, and you know this L value is a constant, therefore r dot equal to 0. But this theta is varying with the time, and therefore there will be velocity, that is r theta dot. Here r is L, so L theta dot. Now we got two velocity vectors, and to find out the total velocity of small m, we have to add these two velocities. So suppose here this is the angle theta, then this one also will be the angle theta. So what will be the resultant velocity? That is v square will be equal to v1 square plus v2 square plus 2 v1 v2 cos theta. That is v square is equal to, here v1 is x dot, that is x dot square, plus v2 is L square theta dot square, plus 2 v1 is x dot V2 is L theta dot cos theta. So we can easily write the kinetic energy, that is half m into x dot square plus L square theta dot square plus 2 x dot L theta dot cos theta. And the potential energy of this mass is minus mg L cos theta. So you can write the total Lagrangian of this system. Please write it here. Another example is a double pendulum. This is a double pendulum. There is one pendulum is there, and to that pendulum one more pendulum is attached. So there are total 2 pendulums. And here I am taking this length as L1, this as L2, and this mass as M1 and this mass as M2. So this is angle theta 1 and this one is angle theta 2. And you can see this is oscillating like this. And this pendulum is oscillating like this. Here also, which coordinate system we are using? We are using plane polar coordinates. In plane polar coordinates, the velocity elements are r dot and r theta dot. Here in the position of r, here it is L1 and L2. So first I am considering the mass m1. So this one is the mass m1. For this mass m1, this L1 value is a constant value. So L dot is 0. Okay, so only one component will be there, that is r theta dot. Here it is L1 theta dot. So velocity v1 will be equal to L1 theta dot. That is this one. This is velocity v1, that is equal to L1 theta dot. So the kinetic energy will be equal to half m L1 square theta 1 dot square. Now I am considering the second mass m2. For the second mass m2, it is attached to mass m1. So this mass m2 definitely will have a velocity v1, that is this one. That is v1 equal to L1 theta 1 dot. And it is oscillating about its own axis like this one. So there is a velocity in this direction. So this is velocity is v2, that will be equal to L2 theta 2 dot. And this angle between these two will be theta 1 minus theta 2. Therefore, for the m2 mass, the velocity v1 equal to L1 theta 1 dot and v2 equal to L2 theta 2 dot, and the angle between them is theta 1 minus theta 2. So the resultant velocity v square will be equal to v1 square plus v2 square plus 2 v1 v2 cos theta. So what we will get? We will get v square equal to L1 square theta 1 dot square plus L2 square theta 2 dot square plus 2 L1 L2 theta 1 theta 2 dot cos theta 1 minus theta 2. And for mass m1, you have to find out the potential v value, and here also for mass m2 you have to find out the potential v, and you have to write the total Lagrangian. This is the work for you. Okay. Another example. Here you already know how to solve for a double pendulum. Here this is L1, this is M1, and this angle is theta 1. Now I am attaching another pendulum to this one with a length L2 and mass M2, and this angle is theta 2. I am adding one more pendulum here. This is L3, mass is M3, and this angle is theta 3. I already told you how to solve for a double pendulum. So you try by yourself and find out the Lagrangian of the system. It's a work for you. Another example. Here one bead is sliding over. Here a bead is sliding in this direction. And also it is rotating about the z-axis with an angular frequency omega. And this angle is given, that is alpha, and the distance is given as r. This is x coordinate. So the question is to find out Lagrangian. That is, we know Lagrangian is equal to t minus v. So first we have to find out t, and from this figure you can easily calculate d. Little difficult one is finding the kinetic energy. But by using this trick, we can easily solve this kinetic energy. I'll tell you. Here you see this bead is rotating like this. About the z-axis, right? So to find out the kinetic energy, we know that is half mv square. We have to know the velocities. Okay, and here we are using a cylindrical coordinate system. And in cylindrical coordinate system, I already told you the velocity elements are rho dot, rho phi dot, and the z dot. And I think you're remembering the cylindrical coordinate system that I already told you. So this one is the cylindrical coordinate system. See, this is x, y, and z. And if there is a particle at this position, and this position vector is r, then the projection on this xy plane will be this one, and this distance is called the rho, and this angle is phi, and this projection on z-axis is z coordinate. Now look into the problem. In this problem, what are the velocity elements? Here you can see the bead is sliding in the downward direction. So there is a velocity in the z dot direction. That is, velocity is z dot. v1 is equal to z dot is there. And another velocity is there in the direction of rho dot. So corresponding to this figure, this value is variation in the rho. So that is v2 is equal to rho dot. And it is rotating about the z-axis. So there will be another velocity. That is v3, and it is equal to rho phi dot. So these are the velocities, and you can see all these velocities are mutually perpendicular. So what we will get? We get resultant velocity v square will be equal to v1 square plus v2 square plus v3 square. That is equal to v1 square is z dot square plus v2 square is rho dot square plus v3 square is rho square phi dot square. And what is this value? Rho dot square plus z dot square. If you check this figure, you can find out this r vector is resultant of rho coordinate and the z coordinates. So this is nothing but r dot square plus rho square phi dot square. Here you can see if this is the angle theta, then rho equal to r sine theta. Similarly, we can rewrite this row value, that is here r sine alpha. And what is theta dot? Theta dot is velocity in theta coordinate. It is rate of change of angle. So the velocity will be angular velocity, and we represent angular velocity by omega. So we can rewrite this equation, that is v square equal to r dot square plus r square sine square alpha omega square. So what will be the kinetic energy? T will be equal to 1 by 2 m r dot square plus r square sine square alpha omega square. And what is the potential here? That is equal to mg z. So you got the Lagrangian L equal to t minus p. It's very easy. See, this method is very easy. You do one thing, you just try to solve this problem by our general equation. So first we take half m x dot square plus y dot square plus z dot square and take the corresponding coordinates in cylindrical coordinate system. So you get x equal to some value, y equal to some value, and z is equal to z. Right? Then take x dot, y dot, z dot and take the squares of it and add it and find out the kinetic energy. I tell you, you get the same value, that is t is equal to half m r dot square plus r square sine square alpha omega square. I recommend you to try it by yourself and convince yourself. And you can see that to solve this problem in the very conventional way, you have to spend at least one full page. But here you see, if you know these ideas in your mind, you can simply write the final Lagrangian. Just look into the diagram and just write the Lagrangian. And you see in MCQ question, the option will be there. So you just look into the option and look into the diagram and just compare those two things. You can easily find out the correct option within 1 minute. So this method is very powerful. Okay, it will help you to reduce the time consumption and the usage of the given rough page. But if you are doing in a conventional way, that rough page will be over by solving one problem. So you can raise your hand in the exam hall and you can ask, Mom, I need one more additional sheet, my paper is over. So it is not possible. So you will get stuck. Okay, so learn this technique. Okay,